Okay, I'm back and we're ready to go on part two here of the mission to the moon. I've got my space suit on and we're ready to go. So this section we're going to talk a little bit about the hardware that's necessary to put three men on a mission to the moon. It takes a lot of big hardware. Um, uh, in the background, you can see a picture or a set of models. Um, that are to scale so that if you were to see them on the pad, they'd all be that size to each other. So over here, this smaller rocket, that's the Gemini rocket that took two men into space. So if you think of this in terms of energy, that's most of the rocket is fuel, that's energy. It takes that much fuel and energy to put two men into orbit. And then here's the space shuttle, and that's the amount of energy with the big fuel tanks and the two solid boosters on the side. That's what it takes to put 7 people into orbit. And then the big tall one here, this is the Saturn V, and that's what we're going to be talking about. And that in relation to the size of the space shuttle and the size of the Gemini, you can see how much energy it takes in fuel mostly to put 3 men on an orbit to the moon. So I'm going to share the screen now, and we'll bring up the presentation again, and we'll do a slideshow from the current slide. Okay, here we go. This is the Apollo program, and of course it's all involved with lunar exploration. So here is our mission. It looks pretty complex, and it really is. So if you can think about this as our Earth over here, our Earth traveling through space around the sun at 66,666 miles per hour. So don't let anybody tell you you're moving slow. While it's moving at that rate around the Earth, around the sun, the Earth rotates around its axis about 1,000 miles an hour at the equator. So you've got this thing spinning through space at 1,000 miles an hour, traveling at 66,000 miles an hour around the sun, and you're trying to hit a target that's about 240 or 50,000 miles away, that's traveling about 2,300 miles an hour. Land the vehicle on the proper place on that moon, and then explore the moon for a few hours, and then come back off the surface of the moon onto an orbit to rendezvous with another spacecraft that's been waiting for you, and then firing a rocket to get you back on a trajectory to the Earth, and then re-entry into the Earth, into the ocean, bringing the men back safely from the moon. So it takes a lot of energy, and the first stage of this vehicle contains huge liquid oxygen tanks and liquid helium tanks. Contains 7 F1 engines, each of those producing about 1.5 million pounds of thrust apiece, for a total of approximately 7 million pounds of thrust. So that's the first stage of the Saturn V. The second stage, we have 5 J2 engines. They're a little bit smaller, don't produce as much thrust, but they fire for a longer period of time and thus accelerate for a longer period of time. And we've changed fuel now from liquid oxygen and having liquid hydrogen as the other fuel. Then third stage, this is the stage that kicks you into orbit. The third stage has 1 J2 engine in it, and it has liquid hydrogen and liquid oxygen for its fuel also. So that's the part that kind of kicks us into orbit and will kick us off into a path or trajectory on the way to the moon. And then the final stage contains the command module where the 3 astronauts are seated. And it contains the service module, which contains all the support equipment necessary to support life for the amount of, or for the length of the mission, and an engine to get us back to Earth from lunar orbit. And then in the lower part of this stack is the lunar module that will land on the surface of the moon. This launch escape system is there only for the first part of flight, only during the booster phase. So if anything should happen during the boost phase, this rocket system will pull the command module away from the service module and put it in a high altitude, and then separate from the command module, and the command module will be lowered back to Earth on parachutes. So that's there for a launch failure purpose. So here is a picture of the vertical assembly building in Florida. And you can see the stack of the launch vehicle there coming out of the building. And you can see that it's a pretty large vehicle. It's the largest building by volume at the time in the world. And just to give you an idea, if you look at some of the cars below, you can get an idea of the size of this equipment. Notice the modern jet helicopter that you see. Here's the first stage laying on its side before it's raised into position in the vertical assembly building. Gives you an idea of the size. About 33 feet across this vehicle is. And each of these engines will definitely hold, if you assume this fellow over here is 6 feet tall, you can see he'd easily stand up in each one of those big F1 launch rocket engines. Here you can see that stage has already been put into position, and they're lowering the second stage onto that first stage. They'll mate it and get all of the electronics hooked up, and they'll keep building this stack. And then finally they'll put in the command module and the service module. Here's the command module for the crew sits in, and the service module that contains all the support equipment, and the rocket engine that will get them from lunar orbit back to Earth again. Here is the lunar module being lowered into the stack, and you can see it's covered in gold, and that's to protect it from the radiation of the sun. Since there's no atmosphere on the moon, the sun's rays directly affect the vehicles. So they coat them in these protective foil, so that keeps the high radiation density from the sun from penetrating the instruments. Here you can see the rocket engine that will lower them to the surface of the moon. Here you can see, these are interesting. These are pads, and the reason that they're on there is that originally geologists didn't really know what the surface of the moon would be like, that maybe if Neil Armstrong stepped off the moon, he'd sink up to his waist in lunar dust. Nobody really knew. So they put these pads on, much like you and I wear snowshoes in the wintertime to keep from sinking deeply into the snow. These pads were added so that the vehicle wouldn't sink so deeply into the surface of the moon. Here is the typical spacesuit that was used. It has an undergarment, and you can see some valves or some inlets and exit points here. And there is circulating fluid through there constantly from the backpack life support systems to keep the astronauts cool while they've got the spacesuit on. This is the exterior part of the spacesuit, and these are all connectors to the backpack. You can see the boots that they wear and the gloves, the helmet, and of course, everything is all sealed, so there's normal 14 pounds per square inch of pressure inside the suit so that they feel like they're inside an Earth-like environment. It's very difficult to work with fine materials like nuts and bolts with these gloves because if you can imagine yourself working with gloves that are pumped up from the inside with air so that they're like working with balloons. So it's very difficult to do tiny manipulations there. In training for landing on the moon, it's pretty difficult here on Earth to simulate the gravity on the moon, which of course is 1/6 less than it is on Earth. So if you want to lose weight, go to the moon because you would weigh literally 1/6 of what you weigh here on the Earth. This is called a flying bedstand, and it's a simulator to simulate the what the astronauts would experience on the lunar landing. In the center here is a jet engine with its thrust in this direction and downward direction, lifting the vehicle upwards. It has attitude control jets on the side to control the attitude, and then a cockpit, which is the same instrumentation that the astronauts would see on the lunar surface when they're approaching a landing. Neil Armstrong had an accident with one of these where one of the side thrusters on the vehicle over in this area stayed on and tipped the vehicle over on its side while it was in the air, and Neil Armstrong ejected and was safely returned to Earth by a parachute. A few scratches was all he had. This is what we were looking at in terms of simulators for the command module itself. This is Mike Collins, the command module pilot. Sitting here, we had no digital equipment at that time. Everything was analog, like with tubes and a few old type transistors. This is what the command module control panel looked like. The central white object that you see here with the keypad, that's the onboard computer system, no more powerful than what you have on your phones today. These are the 8 balls, the round circular objects that you see are 8 balls like you'd find on an airplane to show you the attitude. And then up here in the upper left corner is something called the EMS, the entry monitoring system. And that's the system I worked on when I was working at NASA. It was used to help the crew in re-entry coming back from the moon. Should something happen to the onboard computer, they could take over manually, and by reading the chart, they could actually manually walk the spacecraft through re-entry. Here is the stack of the vehicle with its gantry, support gantry over here on the right. And it's getting ready for launch. You can see the vehicle, its total length is over 300 feet. It's more than the length of a football field. Here's another view of it as you looking out towards the ocean, almost at the same level as the command module here. And you can see the escape tower here, and then the third stage, second and first stage of the launch vehicle. Here's the vehicle standing on the pad, and I show you this for 2 reasons. First of all, there's very large clamps sitting around the spacecraft, and these clamps hold the spacecraft down on the pad until all the instrumentation says that the thrust is built up to its normal thrust amount, and then they will release the vehicle on its way into space. Down here, you can see some netting, and the netting is there because we're down at the near the swamps there in Florida, and there are such things as alligators and coyotes roaming around. So those are there to keep varmints from getting into the vehicle. That'd be a pretty surprised varmint if that thing went off when it was on there. Here you can see this ring on top of the second stage is where all the instrumentation is housed, telling the engineers the status of all of the workings of the rocket engines and the pressures and all the other dynamics that are necessary to monitor. These are all the cables that are there, used before it leaves the pad to check the vehicle out while it's on the pad. After it's on the pad, everything is done by radio telemetry. Here's the view the day of the launch. And I always like to point out to everyone, I always ask, how many women do you see in the Launch Control Center here? And there are very few. At the time, there were not very many engineers that were women, but there's one sitting right here. And there's also some women back here observing, and I would imagine that they are secretaries to some of the launch control people. There is a person right here from Wisconsin. That's Deke Slayton from Sparta, Wisconsin, who was one of the original 7 astronauts and was in charge of the crews during these lunar launches. And this is Dr. Werner von Braun. He is one of the German engineers that came back from World War II, along with some V2 rockets, and they're the ones that started the rocketry program in the United States. And it's Werner von Braun here who had the dream of going to the moon and coming back safely. So I'm going to stop here, and this is our crew. Neil Armstrong on the left, Buzz Aldrin on the right, and Mike Collins, who is the command module pilot, in the center. So I'm going to stop here now, and we'll pick it up with a launch and then our way onto the lunar mission.